Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about priority scheduling, and it is non-primitive CPU scheduling, right? So I am going to take a same example in my previous video I have taken for priority scheduling with primitive data structure, that is data CPU scheduling. Here also the same thing. It is straightforward and the answer will be very simple comparing to the previous primitive priority scheduling. Let me show you. So this is the solution to be found for the question has been given. Process ID is there, 5 process, arrival time, bus time, and priorities are there. Here highest priority is 1, lowest priority is 4, and these are all the bus time. Sorry, these are all the bus time, these are all the arrival time. Now say, among this particular process, which particular process will take the CPU first? P1. Okay, why? Because it is arrival time is 0. Even though the priority is very low here, it will take the CPU because whenever P1 arrives, no other process has been arrived. That is the point, right? I need to register this one more time because we need to be very clear why we are going for this P1, because it is a very low priority. Why you are not taking P5? Because it is high priority. You can check the P5 is high priority, but it arrives at the arrival time for P5 is 4. No CPU will wait for other process with the highest arrival time. It will always look for the existing process which is in ready queue. I hope you understand what is ready queue. The ready queue will have whichever process has been in the queue to be executed will be taken for processing. Right now, so here it is. So P1 is coming inside. It is non-primitive, right? That means in non-primitive, whenever the process which is taken a CPU will never leave the CPU unless it completes its task. You can compare this video and also my previous video. I was explaining differently for P1 for primitive. Here it is non-primitive. That's the point. So what is the bus time for this particular P1? You can check it here. Bus time for P1 is 4. So it is not leaving the CPU. It is taking starting from 0 and it leaves the CPU exactly after completing it, right? So P1 execution time starts with 0 and exactly ends by 4. So now after this P1, and what is the timer it clocks here? You can check it. The timer it clocks here is 4. Now we are going to check that by the timer 4, you can check it, all the process has been arrived. When this P1 has been taken the CPU to execute, and no other process will interrupt, right? Why? Because it is non-primitive. So forget about this, it is primitive. Now I have taken only this particular question. So by the time this P1 completes and it ends at 4, all the process arrive. Now forget about this arrival time. Please check only this particular priority. Don't check the bus time. If you are checking bus time, then it is SJF. If you are checking priority, then it is priority scheduling. So here, after completing this, I will show you that after P1 completes, timer clocks at 4, and by the timer 4, all the process arrived. Now we need to check only the priority. Now please check what is the next priority, highest priority, P5 and P4. I was repeating this for one more time. Whenever two processes arrived at the same priority or bus time, we need to take only the process ID which is lower. Okay, small process ID, 4 and 5. Which one is small? P4. Right? So the small process ID will get into CPU. Let's check how long it executes. Since it is a non-primitive, it will complete the fuller task. Right? So it started 4 and its bus time. So process 4 bus time is 5. So it is taking the CPU 4 plus 5, 9. Followed by next highest priority is P5. Right? Here it is. After completing this P4, the next highest priority is P5. Now it is taking, what is the bus time? Is 2. The process 5 bus time is 2. So it starts exactly by 9, it exactly by 11. Right? And process 3, it is coming next. Why? Because the next highest is process 3. So it is coming next and the bus time is only 1. So you can check it here. So process 3, burst time is only 1, starts by 11 and ends exactly by 12. And finally P2, and it has a burst time of 3 and it starts exactly from 12 plus 3 and it executes till 15. So this is how the Gantt chart has been made for non-primitive priority scheduling. So let's find out the total waiting time, that is a waiting time for each and every process here. Total waiting time minus execution time minus arrival time. So process 1, total waiting time is 0. Arrival execution time is also 0. You can check it. Process 1 is not executed anywhere in future and previously also. Right? The execution time for P1 is 0, not 4. It is burst time. It is not execution time. Execution time in the sense process 1 previously has been executed anywhere. If it is executed for 2 minutes or 1 minute, you need to mention here. So the execution time for every process will be 0 here. I'll tell you why. And minus arrival time is also 0. So P1 is waiting time is 0. Let's get into P2. P2 total waiting time, that means it is waiting time here, you can check it. Total waiting time is 12. Previously it is not executed anywhere, so the execution time for this P2 is also 0, minus arrival time for this P2 is 1. So totally 12 minus 1, that is 11. Let's talk about this P3. P3 waiting time, you can check it here. P3 waits till 11. 11 after 11 only this P3 is getting executed. So you can check it over here. That is total waiting time for P3 is 11 minus execution time is 0. Why? Because P3 is not executed previously. That's a point. So minus 0 minus 2. So totally 9. P4, that is total execution time is 4. Total waiting time is 4 minus 0 minus execution time is 0 minus arrival time is 3. So totally 1. So P5 is equal to total waiting time for P5. One more time you can check it this. Total waiting time of P5 is 9. Total waiting time for P4 is 4. So P5 is 9. You can check it. P5 total waiting time is 9 minus 0. 0 is called as execution time because, one more time, you can check it. P5 is not executed previously. Nowhere. So minus what is the waiting time for this, arrival time for this P5 is 4. So totally 5. So now take all the answers. Average waiting time is equal to addition of all this divided by 5. That is the answer for this. Right? So I hope, again I am giving the overview for you. So I hope you understand the video. So this is all about non-primitive CPU scheduling, and the scheduling algorithm is primitive scheduling here. I hope you understand the video. Thank you.